Okay, we are on to the mechanism of breathing, which it says it's called ventilation. Of course, a machine that does it for you is called a ventilator. So, movement of air from outside the body into the bronchial tree and alveoli, followed by the reversal of air movement. So, basically, air moving in and out of the lungs. That's ventilation. On average, does a person breathes about 12 to 15 respirations a minute. It depends on a number of factors going on with physiology and things like that. You count the way the chest rises and falls. So, the process of how do you breathe in? There's really two parts to this. Now, this area here, you want to go to, this is on our PowerPoint. So here's how this works, and this is a little mind trip. We have an atmosphere on planet Earth. Mars does not. Mars lost its atmosphere millions of years ago. So we can't breathe on Mars. And yes, the temperature difference, the fact that we wouldn't last but a couple of minutes. But anyway, we have an atmosphere on Earth. And that atmosphere is what allows us to get oxygen down into our lungs. And it's by a process called inspiration. Now, what this picture is showing, and I'm sorry about the writing being so small, 760 millimeters of mercury is what the atmospheric pressure is at sea level. And it's showing the exact same number here, and that's accurate. When a person is not breathing in and the muscles involved with breathing are not working, the pressure in the chest and the atmosphere is exactly the same. If you know anything about diffusion, osmosis, those kinds of movements, there has to be a gradient. Okay, and you can do two things. You can either increase the pressure in your chest, which you cannot do, or increase the atmospheric pressure, which is something also, unless you have a machine that you can sleep in that would raise the atmospheric pressure, you can't do that either. So what you can do physiologically is lower the pressure in the chest to where now there's a gradient where the pressure on the outside is lower than the pressure on the inside. And that's what when a person breathes in, that's what they're doing. And it's there's a couple of things that are going on. The ribs, what are called the intercostal muscles, are contracting, and the diaphragm is contracting. But that's what has to happen. The pressure inside here has to drop slightly, not very much, for for air to move down into the trachea. Yeah, and it's called Boyle's Law, and you can see a diagram for that in a minute. So what will happen is, this is what normal function, inspiration, breathing in, this is what happens. The diaphragm, when it's relaxed, is dome-shaped. It's going to contract and push down on organs, which is going to increase the size of the chest cavity. And when that contracts, it increases the length, and then what are called the external intercostal muscles between the ribs, they're going to pull out like that, sort of out and up. And that also increases the size of what's called the thorax or thoracic cavity. And by doing so, it's going to drop the pressure inside just slightly, and therefore air is going to move into the lungs because we have an atmosphere. Atmospheric pressure forces it down to the lungs. So here's no breathing, and then see this is pulling out, and see here's the number 760 millimeters of mercury, and you see once the diaphragm presses down and it's pulling out and up, 758, now you have a gradient, and now air is going to move into the lungs. And it does require energy because there are all these muscles contracting. Now, expiration is pretty easy. And if you've ever dealt with lungs in our lab, we have pig lungs. They're very flexible. So what ends up happening is expiration or exhalation is passive. Okay, and that's what ends up happening is the muscles here, the diaphragm relaxes, and the organs actually kind of push back up again, and these external intercostals relax, and the lungs recoil, and air moves out of the lungs. And it does say there it does increase temporarily to higher. I said you can't raise it inside. It does temporarily, but it's relaxation of the diaphragm, and then relaxation of the external intercostals. Breathing out is passive. If you want to have a more forced expiration, like the person in the video that you're going to see, if you want to breathe out super hard, well, that's going to require some other muscle movements.
Pulmonary ventilation, or breathing, is induced by changes in the volume of the lungs and the air pressure within them. During normal inhalation, the diaphragm and external intercostal muscles contract and the ribcage elevates. As the volume of the lungs increases, air pressure in the lungs drops below atmospheric pressure and air rushes in. During normal exhalation, the muscles relax, the lungs become smaller, pressure inside them rises, and air is expelled. Boyle's law explains this relationship between volume and air pressure. An increase in the volume of a container lowers the pressure of the air inside. A decrease in the volume raises pressure in the reduced space. The body's demand for more oxygen can change normal breathing to forced breathing. Additional muscles increase the changes in volume of the thoracic cavity so that more air can pass in and out more rapidly.
Respiratory volumes. These are used, they're measured by what is called a spirometer, and these are actually volumes you would take during what's called a pulmonary function test. If you don't know what those are, watch this short introduction to what a pulmonary function test is, and you'll see in the video the lady that's doing the test, the thing she's blowing into is called a spirometer. It's got a mouthpiece. If you're wondering what is a pulmonary function test, like where are we getting these lung volumes from? If you saw that lady blowing into, and that was very quick, and here's a doctor explaining everything. There she goes. See how she's blowing into a machine and you're getting a readout such as that? And he's explaining what she's doing, but what that machine is doing is measuring her lung volumes. And it says the test can take, there's the actual mouthpiece, and if you notice back there, it's showing all the different equipment, but she wears a clothespin on her nose to make sure all the air is going through her mouth. And the respiratory therapist will actually be giving her instructions, breathe in, breathe out, that kind of thing. All right, and here we go. So there she's breathing in, or it looks like she's pushing her. She's expiring. But you get the idea, and I was hoping this video that we're going to leave a little longer on. Now there's the fun part. You get to find out, because your weight matters with your breathing volume, and I guess it does to a point. Your height is what really matters. But there's the respiratory therapist, technician, giving her instructions, and then she's going to put the clothespin on. Those mouthpieces are kind of rubbery. I used to do these. And then, you see she's blowing into the machine. And that's how you get these lung volumes that we're talking about. Okay, so you saw that video. You saw what she was doing. She's blowing into that machine. There was a tech there that was helping her. She had a clothespin on her nose. And you're given different instructions. Either breathe normal, breathe out as hard as you can, breathe in as hard as you can, do all these different things. And this is what you get on a readout from those pulmonary function tests. Tidal volume is a normal breath. The amount of air taken in and expelled with each normal breath is about 500 mils. The inspiratory reserve volume is the amount of air that can be taken into the lungs, and that machine will actually take the tidal volume out of that. That's why it says in excess of tidal air. The expiratory reserve volume is how much air can be blown out of the lungs. That's actually a smaller number. Once again, those machines will take out the tidal volume, so they're just getting what it's like a person's breathing out normally, and then whatever they can get out of their lungs beyond that point. Same with the inspiratory reserve volume. Vital capacity is all three of those. It's somebody taking a breath and blowing into that machine as hard as they can. And this is probably the most common one. It's a predictor for lung function. It's the tidal volume, inspiratory reserve volume, and the expiratory reserve volume. All three of those together. Minute respiratory volume is the amount of air that moves in and out of the lungs in the minute. It's the tidal volume multiplied by the breathing rate. That's a common one too. The residual volume is the amount of air that stays in the lungs at all times. A person takes their first breath when they're born, and there's actually still some of that left in the lungs. It's called minimal volume. But that's to make sure that the lungs do not collapse. And even after the strongest expiration, you do not lose the residual volume. It's there at all times. Only if the lungs collapse is it gone. Functional residual capacity is what's left in the lungs after a normal breath. It's kind of weird. A normal tidal volume, whatever's left after that, is called the FRC. You don't see that one much. Inspiratory capacity is the tidal volume plus the inspiratory reserve volume. And total lung capacity is the vital capacity and residual volume. That has to do with a lot of things: your height, how tall a person is, a little bit of age. You can do some things to increase that. And this is what a readout would look like. These smaller up and downs are tidal volume. This is a big breath in. This is like the IRV. This is the ERV, expiratory reserve volume. That's an inspiration. And then you can see here, it'll say something over there, vital capacity. You see it encompasses all three of those. So from right here all the way to there is the vital capacity. But this is what a computer readout would look like. Now, under control, you have to know the part of the brain that controls breathing. It's the medulla oblongata and a little bit of the pons. If you remember in the brain, I'm going to go down. Remember the pons was that kind of area that was, it's a landmark. It's got nerve tracts going up and down and sort of transverse as well. Well, this is where you find these are groups of neurons, and their whole purpose, especially these bottom two, especially the blue, it's called the ventral respiratory group. It sends out electrical impulses called action potentials down the what's called phrenic nerve down to the diaphragm, and also the external intercostals. It controls breathing. This is called the dorsal respiratory group, which is involved with more forceful expirations. Like I was saying, breathing a lot harder, like during exercise. And this is called the pontine respiratory group, which you can see it kind of, it influences the dorsal group. I've also read where it has influences on the ventral as well. But if something happened to that, this dorsal group would be firing all the time, and a person would be taking giant inspiration expirations. So the basic, well, here we go. So the dorsal respiratory group, more forced breathing, it's in the back, it's called the dorsal, especially forceful expiration. The ventral respiratory group is the basic rhythm of breathing. Like I was saying, at rest, it sends out a signal 12 to 15 times a minute. And it's this part here. They are colored, but basically when you see things like this, it's just a little group of neurons, and then these are the nerve fiber connections. The pontine respiratory group does influence both dorsal and respiratory group that you can see in this picture. It looks like it's only connected to the dorsal. So here's the entire diagram. Here's the pons. There's the medulla, and see this is now officially the spinal cord. Remember, here's the there's the fourth ventricle. This is part of the cerebellum. That's the aqueduct of Sylvius, or cerebral aqueduct. It goes back this way. But see, here are the nerve connections. There's the phrenic nerve. Here are the intercostal nerves. See, they come down and innervate right there. And that's how that part of the brain is able to control breathing. And then the phrenic nerve here is involved with the diaphragm. So it causes the diaphragm to contract and push down. And these are the ones I was talking about. The internal intercostals are really involved with forced expirations, but in a normal breath, remember the external intercostals are the ones that are pushing like out and up. Okay, and I will start there next when you'll be out of breath.